All right, y'all. So test for a review. All right, so the first problem is one where they want us to graph. So they want us to graph y equals 1/3 to the x. Now they'll give us 4 pictures to choose from. So I'm going to do it on a calculator. And then just sort of sketch what I get, okay? So I'm going to go to my y equals. All right, so y equals, and that was 1/3. So I'm going to use my parentheses, 1 divided by 3, close parentheses, and then my exponent was the x. All right, now you can also use the alpha y equals and get the fraction notation if you want to do it that way, okay? All right, so we just want to hit graph and see what the graph looks like. So notice it comes down from the left side, crosses the y-axis at 1, and then it follows and makes a horizontal asymptote with the x-axis. But y'all notice it's not crossing the x-axis, okay? So we would choose the picture where it came down on the left, and then it's just sort of getting closer and closer to the x-axis on that, okay? And I'm actually going to show y'all that. So if you notice, they got 2 that are close, but y'all, that one's crossing under the x-axis. We need to be like C, where it comes down and sort of makes that horizontal asymptote there, okay? So be careful when you're choosing the graphs when they got some that are similar. All right, so then number 2 and 3 were describing the graph. So they're giving me f of x equals 2 to the x plus 4. So they say start with the graph. Y equals blank to the x. And then it says you'll have 4 answers, A, B, C, D. They'll say shift the graph 4 units to the left, shift the graph 4 units to the right, shift the graph 4 units up, or shift the graph 4 units down. So what we got to actually figure out is what's happening when you add 4 to the exponent. Well, y'all, this will be horizontal. It will be left or right. And since that 4 is positive, this thing will move left. So remember, the exponent, positive moves me left, negative moves me right, okay? All right, so down here, start with the graph of y equals. Well, my base is 2, so I would put my 2 into blank, and then I would choose the one that says shift the graph 4 units to the left. Now, after we do that, we then have to graph it. So remember, graphing in MathLab, we choose the exponential tool, which looks like a curve going to the right. So you choose the exponential tool and click on the graph. Once you click on the graph, it's going to put the graph on there. Then it's going to open up that little box on the side. So since this was a horizontal left, we're going to move the horizontal to a -4. Okay, so you're sliding that horizontal to -4. So that moves it. Now remember, the last thing you got to do in the bottom left corner, it's going to say base. Remember, by default, they got an E there. So we need to change the base to match our problem and put our 2 in there. Once you do that, it's going to move the graph and then you're done. Okay. All right, y'all. Number 3 was basically the same thing. It wants us to describe the graph. All right, and this one I got f of x equals 2 to the x plus 5, and then it's got -3. So it starts out the same way. Start with the graph. Y equals blank to the x. Now they've already got the x there, okay? Then it says shift it blank 5 units, and then shift blank 3 units. So y'all, let's fill this in. So what's going in the first box? I'm going to start with y equals what to the x? So what are we putting in that box? All right, so here comes my chat. Let me get the chat going. All right, y'all, good job. It is definitely a 2 because my base is a 2. Now, shift it blank 5 units. Well, here's your 5. It's been added to the exponent. So what am I putting here? Up, down, left, or right? What are you saying? Nancy, y'all are saying left on that? Good job. So just like above, when it's being added, it went left. And then how about this one? And then shift it blank 3 units. Well, that 3's been subtracted at the very end. So up, down, left, or right. Jacob, you got down. Good job. Okay. Now remember on Math Lab, same thing up here. You're going to choose the exponential tool and click on the graph. Now we got 2 moves on this one. So the horizontal, you're going to move horizontal to a -5. Because remember, -5 on that slider means you're moving left over to 5, okay? And then we went down, so then you're going to move the vertical to a -3 since it went down. And then remember, base. Now, our base is a 2 again. It may keep the 2 in there since you used it on the last problem. If not, it'll have an E here, and make sure it is a 2 in the base. So y'all, once you do that, it's moved that graph for us, and we're done, okay? Alrighty, so number 4 is an investment problem. Okay, so let me give you the information. So first they're saying $76,000 is invested at 5.5% interest. Whoops. And then this is compounded quarterly. Okay, so that's the info they gave me. So this is the part A and a part B question, okay? So part A, they want me to find the function for which the amount of the investment grows after T years. So remember, they just want us to come up with the formula we would use. Part B, they're going to give me different times to use for the T, okay? So remember, the basic formula was A of T. Remember, the amount at any time T equaled P, which was my starting amount, times 1 plus R over N raised to the N times T. So they want us to come up with our formula that we would use for this problem. So y'all, they're giving us the A of T. We got to fill everything else out. So I need my P. Well, they gave us P right here, right? They said we're investing 76,000. So that's my principal I'm starting with. Then the formula has 1 plus R. R is the interest rate. So if R is 5.5%, turn that into a decimal for me. Because we want it out of percent, okay? So basically, remember, 5.5% is like 5.5%. Okay, so that's 5.5%. But now, remember, I got to turn it from percent into decimal. So we need to move that left twice. And y'all, that's going to give me a 0.055. Okay, so turn the half into the 0.5 and then move the decimal left twice, which meant you had to add a 0 there, okay? So 0.055. All right, N, that's the number of compounds per year. So y'all, it said quarterly. What am I putting in for N? All right, let's see, Victoria, 4, good job. And then this will be 4 times T. So the N goes at the bottom and at the exponent. Now, remember this problem, although this is correct, MathLab wants us to turn this into a decimal number. So bring down to 76,000. On the calculator, if you do 1 plus 0.055 divided by 4, that's going to give you 1.01375, and then my 4t. This is what MathLab wants. It wants you to figure out the 1.01375 that you get from that. It now considers this the simple form, okay? Now B, I'm probably going to use the calculator on because it wants me to find the amount in the account after t equals 0, 4, 5, and 10 years. So basically, they want me to find A of 0, A of 4, A of 5, and A of 10. Now, I can do these individually, put a 0 in for the t, see what I get. Put a 4 in, see what I get, okay? Now, I'm just going to get my times ready. And then I had what? T equaled 5, and then t equals 10. Well, y'all, I'm going to show you a quicker way to get these 4 amounts than punching that in 4 different times, okay? Now, look here, that's a t equals 0. If you're investing $76,000 and 0 time has passed, how much you think's going to be in that account? So Victoria, correct. I'm hoping there's a 76,000 when I started, okay? All right, y'all, so I'm going to punch in my 76,000. And then I had what? 1.01375. Whoops, that's a 5. Close parentheses. And then my exponent is 4 times t. But y'all, if you're using the calculator to use the table, you got to use x's as the variable, okay? Although it's a t, really, we got to use an x on the calculator. Now, I don't even want to look at the graph. I'm going to go to the table. So I'm going to hit second graph for my table. And I'm going to bring my x's up to 0. So y'all, when x is 0, look at that. We got $76,000. And that's what Victoria told me. All right, so now if I go down to the 4, that'll be like t equals 4. At that point, I've got, so you see, if I click on the y value, how it's giving me the decimal. But we don't need decimal forms. It wants it rounded off to the nearest dollar. So we want to use the 94,560. See, if you use the table, you can look at what the decimals were when they started, but the calculator rounds them off for us, okay? So next was 5. So that was 99,869. So that's how they rounded that one off. Now, if you punch them in individually, you know, putting in a 0 for the t and then coming back and doing a 4 for the t, it's going to give you the decimal approximations. So you'll have to round them off, okay? All right, so 5 was 99,000. So now we got to go down to 10. And at 10, I got 131,235. Okay, so use that calculator, okay, because it'll get them done quick. And it rounds them off if you use the table, okay? All right, y'all, so 0, 4, 5, and 10, those were my 4 amounts. And notice it went up. It has to go up each time if it's an investment, okay? All righty, so next I got us, you remember Melissa from the problems? So we got her back again. So number 5, Melissa's 6th birthday. She gets a $2,000 CD that earns 4% compounded semi-annually okay, 2000 CD, 4% interest, compounded semi-annually. How much is going to be available? So how much available on the 10th birthday? So that's when this is going to mature. It matures on her 10th birthday. So we want to know how much money will be available. So we're still using our formula. A of t will equal P times 1 plus R over N to the NT. So what we got to figure out is what is our T going to be? How many years have passed between that 6th birthday and that 10th birthday? And y'all, I'll just subtract that, right? I got what? 10 minus 6. So that means our time is 4 years. Oh, I see y'all popping up now. So good job, Victoria, 4 years. So that's what we're going to put in for T on our formula, okay? So we're finding the amount at 4 years. That's going to equal my P. Well, y'all, they gave me the starting amount, 2,000 times 1 plus. All right, this is 4%. I need y'all to tell me 4% in decimal form. What would y'all put there on top for my R? Okay, I'm seeing point. Well, okay, so Victoria, I think you was right, and you got persuaded by Jacob, I think. Look here, you got 4%. But remember, at the moment, the decimal is behind that 4. When there's not a decimal shown, it's behind the 4. So look here, we're going to move once, twice. So I'm only adding 1 0, so that's going to be a 0.04. Okay. And if you'll take that 4%, divide by 100, you'll get a 0.04, okay? All righty. What is my N? What is my number of compounds if it's semi-annually? All right, Reed, good job. That's 2. So y'all remember, semi-annually is 2 times a year. So then we got our N again, which is 2 times our T, which is 4. So what we're going to do, this one wants it rounded off to the nearest cent. So that's 2 decimal places. So let's go punch that in and round it 2 decimal places. And I'm just going to punch it on the front. I got my 2,000 parentheses 1 plus 0.04 divided by that 2, close parentheses, and then my exponent was 2 times 4. All right, so remember, it's got to be more than 2,000 because that's what they started with. So after 4 years, let's hit enter. We got 2,343. All righty. What are y'all rounding it off to? 2 decimal places. Are y'all going to keep that at 31 or y'all going to make that at 32? All right, 32. Good job. So the 1 got rounded up because of that 8, y'all. Okay. All righty, so make sure you go 2 decimal places on that number 5. All right, y'all, now it's time for the calculator for a little bit. They want me to find the logarithm. All right, let me make sure one thing here. All righty, so this is a log 10 of 0.1. Now remember, since that's a log 10 for the base, that's the same as the log on front of your calculator. So in front of that calculator, all you got to do is punch in a log 0.1. And what's that equal? Or if you want to make it with the base, you can use that log base that's in the math feature, okay? All right, -1, y'all. So decimals and fractions give me negative exponents. All right, number 7, find the log. So I'm just going to use shorthand on that logarithm, okay? All right, so let me see. Number 7 is a log base 4 of 4 squared. And we actually had a rule about this. When the base of the log matches the base of the result raised to an exponent. Now, I would use the log base. I would hit math. I would arrow down the log base.
Would it be 2?
Oh, what did you just say? I think it's right.
Would it be 2?
It'll be 2. And y'all check it out. Anytime that base matches the base of the result, the answer will always be our exponent, okay? All right, try this one. Find the log of a log base 81 of 3. Now listen, this one says write the answer as a fraction. So they don't want the decimal answer. So if you get a decimal answer out of that, hit math and enter twice to turn it back into a fraction. So y'all, if y'all punch that one in, what are you getting?
I done muted myself. Would it be 1/4 as a fraction?
1/4. There you go. So that probably gave you a 0.25 as the answer?
Yes.
Uh-huh. So if the result where the 3 is smaller than the base, it's going to be a fraction, okay? All right, try this one, number 9. Find the log again. This one has a log base 7 of a 1. Now, y'all should be getting that in really quick because here's a base of 7. Here's a 1 for the result. Only one exponent has that power.
0.
Oh, y'all are getting it online. Okay, much. Victoria, yep. And Paris, y'all saying what, 0? Good job. So I don't care what that base is. If that's a 1 there, you're going to put me a 0, okay? All right, now look here at 10. They want us to convert to a log equation. Now remember, this is the stuff where I had log a of y equaled x if and only a to the x equals y. So this is the conversion I use when I convert, okay? Now they want me to go into a log equation and they're giving me the exponential. So the problem they're giving me is 10 squared equals 100. So remember, this is the logarithmic side. This is the exponential. So we got to write it with a log. So the first thing I do is put my log down. So what's the base of this log? Well, y'all look here. The base of the
Is it
log
is it
is equal to the base of the exponential.
it's a 10.
It's going to be 10. The result is the same as the result of the exponential. So you see they got the y there because y was the answer they got. So that's going to be the 100. Because remember, log 10 of 100 equals what exponent? We all look here. The exponent's what the log equaled. So that's going to be the 2. Good job. So see, the log base 10 of 100 equals 2. So that means 10 squared equals that 100, okay? Right now there's 2 doing that. So this one says convert to a log equation. E squared equals m. So if we're going to turn it into a log, we got to write log. So I need the base. So what's my little subscript base going to be? All right, so look at my pattern. I'm looking for the A. So the A, that's E. So you got to bring down your subscript E. What result goes next? So that'll be the M. And once again, that'll equal your exponent of. All right, one more. Okay, 2. There you go. Okay. All right, so that was going from exponential to logarithmic. On number 12, we're going to convert from logarithmic into exponential. So these will say convert to exponential. So for 12, they're giving me a log base 6 of 36 equals 2. So here's the first question. What is going to be the base of my exponential equation? So 6, yeah, because the base of the exponential is the same as the base of the log. All right, so you got a 6 there. What am I putting for the exponent? What's going to be my x? All right, so that's going to be a 2. And 6 squared equals my result of a 36. All right, so y'all doing it online. Good job. Now, knowing that, let's get this next one, okay? 13, convert to exponential. Now they're going to trick it up a little bit on this 13. They got a log base A of a capital M equals a negative Y. Now, you have to make the M capital when you write the answers in the math lab, okay? But I think, let me see. Yeah. All righty, so I guess I need the base. Well, guess what? The base is the A. The exponent is the negative Y. And that's going to equal my result of a capital M. Okay, y'all, so remember, for these 4 problems, I'm following this conversion, okay? from logarithmic to exponential, exponential back into logarithmic. All right, 14 says use calculator to find natural log. So they're giving me a ln 326.1. Well, the LN's on the front of your calculator. So punch that in, and I need y'all to round that out 4 decimal places. So they want 4 decimal places on this one. So you'll have a something point with 4 more numbers, okay? So I'm gonna let y'all punch that in and see what y'all get. All right, I got some answers coming in. Let's see, 5.78. Perfect. Perfect. 5.7872. All right, now 15 says find the log using change of base. Well, that was old terminology. What we want to use is the log base on the calculator, okay? So you want to go to math and then down to that log base. But I want y'all to find that of a log base 4 of 17. Guess what? You're going to round this one 4 decimal places. So a little bit more work because you got to go hit math and go down and get that log base. But y'all punch that in and see what y'all get. Round me 4 decimal places. 2.043. Perfect. 2.0437. Good job. All right, y'all. Now we're going to start getting into those properties we learned. So these were from section 9.5, okay? All right, let me get this back up. So 16, express as a sum. So if they want me to express it as a sum, those are the ones where I started with the product. And this would be the product rule of the logs, where I started with a product and I rewrote them as a sum, okay? So the product we're starting with is a log base 11 of 11 times 121. So express it as a sum means they're going to be added. So all we do is we distribute the log 11 to both factors and put a plus in the middle. So I get a log 11 of 11 plus my log 11 of the 121. And y'all, we don't go no further because they didn't want me to evaluate it no further. I mean, this would equal 1 and this would equal 2, but they didn't want me to do all that. They just wanted it rewrote, okay? So don't go too far on that. 17 wants us to express as a product. Well, the ones that say express as a product, those are the ones where I had the exponent up here and I brought the exponent down to the front and made it a product. This was using the power rule of logarithms. So they're giving me a log base m of a t to the 7th. Now they put parentheses, but they're not needed here. The only thing I'm still going to do to rewrite this as a product is we're going to bring that 7 down to the front so that this becomes a 7 log m of t. It's now a product between 7 and that log, okay? And y'all, we don't go no further. Now this 18, it says rewrite as sums or differences. So we got to figure out if we're going to rewrite them as addition or as subtraction. So remember, if it's a product, I rewrite them as sums. If it's a quotient like a fraction, we'll rewrite those as differences. So here's what they're giving me. They're giving me a ln of x to the third, y to the third, and a z. Well, this stuff is being multiplied inside these parentheses, right? x3 times y3 times z. So we're going to do it up here. It's going to be rewritten as a sum. Okay, that's why they got the or here. So it's going to be written as a sum, and I'm going to distribute the ln to all three. So I get a ln x to the third plus ln y to the third plus the ln of the z. Now, tell me what I need to do next, because I definitely got one more step. Oh, y'all done slept since that 9.5, huh? Well, I'll give y'all a clue. It has to deal with these exponents. Okay, Kana, there you go. We got to move these two exponents to the front. So remember, we got to do the power rule if we got exponents, so that we get a 3 ln of x plus a 3 ln of y plus my ln of z. Y'all don't forget, bring those exponents down, okay? So that they'll be in the most simplified form. Well, all right, y'all, let's see. Number 19. This one says express as sums and differences. So up here, the or meant either or. It was going to be one or the other. This got an and in it. So that means you're going to have some sums and you're going to have some differences. So y'all, here we go. We got a log base b of P4 Q7 over M5 B8. Now, the sums and difference, that comes in based on where they are on that fraction. If they're on top, they're going to be positive or added. If they're on bottom, they're going to be negative or subtracted, okay? And we're going to distribute that log b to all four of those. So starting on top, I get a log b of p to the fourth plus a log b of q to the 7. So the two top factors are both positive. Now everything else is coming from the bottom. We're going to subtract them. A log b of m5. And then minus my log b of b to the 8. All righty, so what are we doing next? Yeah, move those exponents on three of them. Three of them, I'm going to move the exponents to the front. But y'all, let me ask you this. What does log base b of b to the 8th equal? Remember, we had a problem earlier where we had like a log base 4 of 4 or something. All right, Nancy and Caleb, good job. Remember, if the base matches the base raised to an exponent, this whole factor is going to turn into an 8. Good job. So bringing the 4 down, 4 log b of p, plus bringing the 7 down, 7 log b of q, minus bring the 5 down, log b of m, minus 8. So remember, y'all's number 19 will have a matching base like this. Okay, so remember, convert that to the exponent, okay, so that you got a single number there. All right, let's see. 20 said simplify. So y'all, they're giving us the ln of x squared plus 7x plus 12 minus ln of x plus 4. So first thing, I'm going to rewrite this as a single logarithm. Now notice, this one's being subtracted like this was being subtracted. Remember, when you got subtraction and their difference, they're going to be rewritten as a quotient. So bring out the ln. On top of my fraction will be the positive stuff. So that's going to be the x squared plus 7x plus 12 over the stuff that was being subtracted, which was the x plus 4. Now, this is correct so far, but this needs to be simplified further. So to simplify this further, you're going to have to factor the top of that fraction. Now, all we got on bottom is the x plus 4, so we cannot do nothing to that at the moment. But y'all, let's see what we get here. X squared is an x and an x. Give me factors of 12, that'll give me a 7. So 3 and 4, 3 and 4, and they're both going to be positive, remember, because the last one's positive. They're both going to be positive like the middle. So they sort of give you a clue, right? There's an x plus 4 on the bottom. If anything's going to cancel, those got to match up, okay? So the final answer will be the ln of, and you got to keep the parentheses with the x plus 3 inside. So make sure on number 20 you factor that top and get that to cancel. All right, y'all, let's see. 21, solve for x. They're giving me 5 to the 9x equals 25. So remember, this is an exponential equation. So the first thing I look for on an exponential equation, can I rewrite each side using the same base? So y'all, can I rewrite a 25 using a 5 as the base? So good job, I definitely can. So bring down that 5 to the 9x. That's going to equal 5. Well, what exponent? How many times you multiplying that 5 to get that 25? So 2 of them, there you go. So this is good because if these bases match, that means the exponents have to be equal. So that means 9x has to equal the 2. So now we're just going to solve that by what? Dividing by 9? So that cancels and I get x equals, well, y'all, we can't do nothing with that. So that'll be 2 over 9. So if you put the 2 over 9 up here, the 9's cancel. 5 squared is 25. So they'll sort of check out if you sort of look at them answers, okay? All righty, y'all. So looks like the rest of these are just going to be equations doing different things, okay? So that was 21. So we're on 22. I'm going to solve. It's another exponential equation, but this one has a 3 to the x equals 10. So remember the first step, can I rewrite this 10 using a 3 as the base? So what y'all think on that? Oh, y'all start multiplying 3 times 3 is what? 9. 9 times 3 is what? 27. So you can't multiply 3 times itself to get a 10. Good job. That's definitely a no. So we cannot rewrite this. So what do I do if I couldn't rewrite it? Because remember, I need to pull the exponent down somehow. If I couldn't rewrite it, I took a log of both sides. So remember, this one we can't rewrite. So since I couldn't rewrite it, we're going to take logs of both sides. So you get the log of 3 to the x equals the log of 10. Remember, we did that. Now we can bring the exponent down using the power rule. So we get an x log 3 equals a log 10. Now, to get this to be a 1x, we divide both sides by log 3. So that'll equal this log 10 divided by log 3. So those cancel, leaving my x. Now, since this one couldn't be rewritten with the same base and we had to take a log, that means you're going to round me 4 decimal places. Also remember, when you punch this one in, log's going to open the parentheses, close it before you hit divide, and then put in your bottom. And y'all, somebody round me out 4 decimal places on that. So I can see if y'all are getting good on punching in these logs, okay? So anyone getting like a 2-point something? Oh, we got to go a little further on that. And so let me show y'all how I'm doing that on my calculator. I think, let me go to the calculator. I think you're just getting a little round off error. So let's see, I got a log of 10, close parentheses, divided by a log of 3, close parentheses. So I got to be 4 decimal places though, y'all. So let's watch this. So that's going to be 2 point. Now look, the 4th decimal place is a 9. So I'm looking at the next decimal place to see what to do with that 9. But it's a 0 in the 5th spot. So we're going to keep that 0959. So Paris, good job. 2.0959. Y'all remember, when you're looking for the 4th decimal where that 9 is, you got to look at the number after it to determine about rounding up or not, okay? And since that's a 0, you got to keep that as a 9. And remember, 4 decimal places means after the decimal, you got to have 4 numbers, okay? All right, solve for x. This is a log equation, log base 3 of 2x minus 7 equals 1. So when you got a single log like this equal to a number, we're going to rewrite this as exponential. So that's how come y'all had to learn how to convert while ago. So the base is the same as the base of the log. That's going to be 3. Exponent will be the 1. And 3 to the first is going to equal the 2x minus 7. Okay, so we're rewriting it just like we did on those problems around number 12 or something like that. All right, 3 to the first is 3. So if I'm going to solve that for the x, I'm going to add 7 to both sides. 3 plus 7 is 10. That's going to equal 2x. And y'all, divide by 2. So that cancels, leaving me my x. And 10 divided by 2 gives me a 5. Okay? So they're given, you noticed on the exponential, they gave you one you could rewrite, one you can't. On the logs, they're giving you a single log at first. Now look here on this one. We're going to solve this one. Log base 4 of b plus 14 minus a log base 4 of b plus 6 equals a log base 4 of a b. All right, so the first thing you got to do, you got 2 logs over here. We got to make this side a single logarithm. So we're going to bring out that log 4. Now here's a question for y'all. Am I going to rewrite this as a product or a quotient? So remember, since it's being subtracted, we're going to write it as a quotient. Good job. So the b plus 14 is going to the top over the b plus 6. That's going to equal the log base 4 of a b. So now look here. The log bases match. I got a log base 4 here, a log base 4 here. When the log bases match, that means that this result equals that result. So the b plus 14 over b plus 6 has to equal the b. Now y'all watch this. To solve that, we're going to cross multiply that, and we're going to put a 1 under the b to make it look like 2 fractions. So I'm going to cross multiply. All right, so let me get my more paper. So to cross multiply this top, this b plus 14 multiplies by the 1. So 1 times b is b plus 1 times 14 is 14. That's going to equal what we get from the other cross. we're going to take the b plus 6, and both of them are going to multiply by the b. So b times b is a b squared plus b times 6 is 6b. All righty, so a little different here. I got a b squared in here. That means we need everything over here equal to a 0. So we're going to subtract b from both sides. And we're going to subtract this 14 from both sides. So both of these got to move over by being subtracted. So b minus b is 0. 14 minus 14 is 0. So y'all, that left side is a big 0. Over here, I got my b squared. 6 minus 1 is 5b. And then the negative 14 didn't have nothing to subtract from, so I'll bring it down as a negative 14. So then, to solve that one, we got to factor. The b squared is a b and a b. This last number's negative, so I know I'm going to have unlike signs. All right, so here's what we need. Factors of 14 that equal 5. So you break out your 14, you got what? 1 and 14, that's not working. Oh, 2 and 7, right? 2 and 7. The bigger number is positive like the middle, so the 7 and the 2 is negative. All right, 7 minus 2 equals 5. We're good to go. So now what will I do? Set both these equal to 0 and solve them for the b. All right, also this one looks like I'm going to subtract 7. And I get b is a negative 7. And then here we're going to add 2. And I get b equals positive 2. So now this one will have a blank that says the solutions is or blank. I think that's how they wrote it. Let me make for sure. Oh, they'll have on this one it says the solution is, whoops, let me rewrite that. The solution is b equals blank. So you don't have to put the equals and all that. But what am I putting in the blank? What's my solution? Oh, I heard it. It's going to be only the 2. Remember, you cannot do logs of negative numbers. So on that one, we're only taking the positive answer, okay? All right, y'all, so let's see. Let me fix my paper here. So, 25. This one says, solve for x. All right, let me see what I got here. Oh, I got a log base 2 of x plus 3 plus a log base 2 x minus 3 equals 4. Victoria, this is the last one, number 25. All right, y'all. So I got to combine the left side into a single log. So will I rewrite this one as a product or a quotient? Okay, a good job. It's a product because they're being added. So the x plus 3 times the x minus 3. All of that equals 4. Now I'm going to do one more step and actually FOIL this. So remember, log base 2. Y'all remember, these are conjugate pairs. And since they're conjugate pairs, we can shortcut x times x and get an x squared. And then 3 times negative 3 is a negative 9, equal to 4. So on your 25, you're going to get conjugate pairs just like I did. That might be a 4 or 5 or something, but they're going to be conjugates. So at this point, I got a single log equal to a number. We're going to rewrite it as a exponential. So rewrite as exponential. So the base is a 2. Exponent is the 4. And 2 to the 4th equals x squared minus 9. So since I just got an x squared term, there's no x's. I got an x squared term and a bunch of numbers. I'm actually going to get the numbers on one side equal to the x squared. So first, 2 to the 4th is 2 times 2 times 2, which is 8, times 2, which is 16. That's going to equal to x squared minus 9. All right, so let's move the 9 over by adding. All right, y'all, that is 25 equals x squared. So I did that because all I got to do now is take me a square root of both sides. Now, technically, you're going to get 2 answers because of that exponent 2. So y'all, the square root of 25, that'll give me a plus or minus 5 equal to my x. But remember, the solution is x equals what? Oh, I see something coming in. Kayla, that's 5. Good job. Remember, I cannot take the negative answer. So at this point, when you do the square root of 25, all you really got to worry about is that positive 5, right? Because you cannot take a log of a negative number. Remember, that gives you an error message, and we said it did not exist on those, okay? So y'all, that is the 25 questions that are going to be on your review and your test, okay? And they're going to go in the same sort of order as I went on mine. So, all right. Come in Tuesday night with y'all. That's going to be our last night of class. So Tuesday night, we will review all 25 questions on the final exam. Okay, so remember, it goes over everything we've learned in 25 questions out of the entire course, okay? I do have the study guide open for y'all already.